Rightio, g'day students, welcome to our lesson today on dilation and scale factor. So by the end of the lesson you should be able to describe and perform dilations on various objects. So we should recall that dilation is a transformation that does not produce congruent figures. So we say it's a non-isometric transformation. Now dilations are described by using scale factor. And we use this formula for scale factor, that the scale factor equals what? The image length over the original length. So remember, the original length goes on the bottom, and then the image length, which is the transformation, goes on top. Now a scale factor greater than 1 indicates an enlargement. That means that the image is bigger. Now a scale factor between 0 and 1 indicates a reduction. That means that the image, or the second picture, is smaller. Now to calculate the side length of the image after dilation, just multiply the original side length by the scale factor. So for example, when dilating a shape with the side AB, use the length of the image side equals the length of the side of the original AB multiplied by the scale factor. So we can also just think if a scale factor is 1/10, the ratio scale there is 1:10. Now I'm just going to click on a interactive so we can have a quick look at this. So we talked about triangles yesterday and we said, well, triangles with the same angle are not a condition for congruence. So here we have two triangles, one over the top of each other. But if I increase it by a scale factor of, let's say, 2, we can see that each side is twice as long as the other. Now that also increases the volume by a lot more than 2, probably by about 4. If I take it up to there, you can see that the volume increases a whole lot. So don't get confused by volume when we're talking about scale factor, or the area on the inside I should say. Am I going to be able to draw it? No, but I can see that this side here, A dash B dash, is 3 times as long as AB. So that tells me that I have a scale factor of 3. I can see also just the point about the angle proof. You can see that the angle proof, although that the 3 angles, or 3 corresponding angles in both the original and the image are the same, the sides are different. So angle is not a proof for congruence, but it is for similarity. Now we'll go and have a look at scale factors below 1. So here's our original and here's our image. You can see that if we have a scale factor of 0.5 or 1/2, that the length of each side is 1/2 of the length of the original. Okay, let's have a look at some worked examples. Now let's describe the dilation from D to D dash. So what we want to do is have a look at a corresponding side. We need to recall our scale factor formula. So let's have a look. We can just choose any side, and we'll go with this one first. So the image length, and this is D dash, so that's the image. So 6 will go on top, and then the original of the corresponding side, you can see that this is the corresponding side, so we'll substitute in 2. So 6 divided by 2 equals 3. Now this should work for any other side as well. So let's have a look at this corresponding side. So that's the image and that's the original. So this time we have a scale factor of 3/1, and that's still equal to 3. Shall we do another one? Let's do it just because it's fun. Let's see, here's our image, here's our original. So we have a scale factor of 4.5 over 1.5. 45 divided by 15 is 3, so 4.5 divided by 1.5 equals 3. So yes, you can see that they're certainly similar. All the sides here are increased by a scale factor of 3. So because each of these are increased in the image, we say that the image is an enlargement of the original. Okay, now let's have a look at this one. We want to dilate this figure by a scale factor of 1/2. So you will automatically know that this is less than 1, so therefore it means it's going to be a reduction. So each of these corresponding sides will be decreased by a factor of 1/2. So 6 multiplied by 1/2 is going to equal 3. 1 multiplied by 1/2 equals 0.5. 4 times 1/2, well, that's going to be 2 centimeters. 5 here, 5 times 1/2, well, that's going to be 2.5 centimeters. So you can see that when we redraw this figure, it's going to be a whole lot smaller. And you can see that here's the reduction, and you can see that it's taking about 1/4 of the volume, even though it's a reduction, 1/4 of the area, I should say, even though it's a reduction of the scale factor of 1/2. So don't get tricked by that, Year 9. Just know when we have a reduction of 1/2, that it will appear 1/4 of the volume, of the area, I should say, again. Okay, I'd like you now to work on the mastery questions for the day, please, Year 9.